Greetings, everyone. To start, I would like to thank Dr. Chan for his efforts and patience in teaching us during these exceptional circumstances. We are from Group 12, and today we will be giving a presentation for our group investigation under the title of Mixed Flow Pump. And without further ado, let us begin.
Pump is known as a device that makes fluid move whether it is fluid or gases by mechanical action. It is typically converted from electrical energy into hydraulic energy. It will operate by some mechanism, thus energy is consumed to perform mechanical work by moving the fluid for development of pressure. Shiduf is the first pump that had been invented by the mankind, which is the Egyptian. It is still used even today in some parts of the world. It is described as hand-operated device for lifting water and it consists of a bucket that was tied to the rope and is used to raise the water from wells, river and more. In the era of Greek, water wheel is invented and it is used to generate power. Those pictures are the example of water wheel and shiduf. Mixed flow pump is a type of pump that mixes features of radial and axial flow pumps, which means that it can cover the transition between radial flow and axial flow. It has the highest efficiency and wide operation range. The flow will enter axially but not necessarily in the center but leaving at some angle between radially and axially. Therefore, it will create enough forces to generate high rates of flow. Mixed flow pumps with higher speed are usually designed with an axial tubular casing, which is also known as axial flow diffuser. For example, mixed flow pump with tubular casing often installed in a vertical arrangement. Therefore, it has bigger inlet diameter compared to centrifugal pump, so the decrease in pressure will be more accurate, especially at pump inlet.
The mixed flow pump is the hybrid pump of centrifugal and axial pump. It have higher mass flow of axial configurations and have higher pressure achievable by centrifugal pump. It also conducive of preventing cavitation phenomenon. The disadvantage of mixed flow pump is it has costly construction fee for higher specific speed range and need longer time for assembly and demolition process.
The pumps are designed to handle large quantities of water and are ideal for a wide range of applications such as flood and water control, large volume drainage and irrigation, raw water intake, treatment plant, circulation of large quantities of water, and lastly, water level control in coastal and low-lying areas. This horizontal mixed flow pump is applicable for transporting clear water, pump transfer with the concentration no more than 3%. This pump usually used in irrigation and wastewater treatment. This pump also can use for clean turbid or slightly contaminated liquid, dewatering and pumping seawater. Medium and low head in water work and sewage also work as one of the applications of the pump. In general industry, this pump used for water circulation in conventional and renewable power station. It also can use for water supply and irrigation supply. The vertical mixed flow pump used in thermal power plant for cooling the water. In ironwork, it used for circulation, drainage and scale pit. This pump also gives a lot of help in agriculture industry and it works as a water pumping and water supply.
Mixed flow pump is a combination of radial and axial flow pumps. It can be referred as a cross between radial and axial flow pump. It is observed that as compared to that of axial flow pumps, the mixed flow pump has a higher operating pressure in most of its application. As with any turbo machinery, pump design requires a lot of effort on finding a right blade profile for the specific application. As there is no right or wrong in the process, engineers have to make some general assumption as a starting point. Generally, we can say that the focus of this task is to minimize losses. The impeller is a very important component of mixed flow pump, and it changes kinetic energy of fluids into pressure. In order to design a mixed flow impeller with enhanced efficiency and suction performance that simultaneously satisfy the pump design specification, various design techniques are required, from a basic design stage all the way through the detailed design stage. When it comes to design techniques, fluid dynamics is essential in order to enhance the performance of mixed flow pump. Designing of a mixed flow impeller blades is still a cumbersome task, mainly due to the great number of geometric parameters. From this date of its invention, various methods have been used for designing the same. These are some research papers containing methodology, process, and calculation on how to design the blade of the impeller. Some of these research papers we have read contain some methodology in how to design the impeller blade. Example of paper, centrifugal and axial flow pumps by Stefano provided design procedure for designing of mixed flow pump for a particular range of blade angle variation. Newman, with his paper, The Interaction Between Geometry and Performance of a Centrifugal Pump, came out with a detailed design optimization with proper steps in the designing methodology of a mixed flow pump.
Now I will be explaining my part, examples and calculations. To start off, I will be showing some examples or applications of mixed flow pumps. Now, these are some of the examples. The first picture shown at the left upper corner is a hydraulic pump which is used in delivering a huge amount of water, usually in an industrial water treatment or in a nuclear reactor, to cool the temperature of the reactor. It's also used for the propulsion of marine vehicles such as submerged crafts, weapon and unmanned underwater vehicles UUVs of various sizes and speed requirements, which can be seen on the right bottom corner. Next, for calculations, we can calculate the pump's specific speed by using the equation displayed on the left upper corner. The value for the pump specific will always be dimensionless. This equation is paired with the diagram below it. The diagram shows the maximum efficiency of the function of pump specific speed. It can be seen the pump specific between 1.5 and 3.5 mixed flow pump will be a suitable choice if the specific speed is customed as US units or European units. We can just basically convert our values and vice versa using the equation in the middle. We can also calculate the power needed by the mixed flow pump BHP in order to operate by using the equation at the left end.
And now to conclude our group investigation, first we will take an overview of what we discussed. First, we discussed about the introduction and the history, where we talked about the pumps that were invented in the 16th and 17th century. Second, we looked into the advantages and disadvantages. Later, after that, we've discovered some various applications, and we've also looked into the efficiency of the mixed flow pump, and we found that it has the higher efficiency amongst the rest of the pumps. For clarification, we went through some examples and their calculations to clear things up. However, we also acknowledge the fact that a mixed flow pump is a type of pump that mixes the features of radial and axial flow pumps. It has many applications ranging from flood and stormwater control to filling and emptying of reservoirs, and we've also seen that the major advantage of mixed flow pumps over the rest of the pumps is that they combine higher mass flow of axial configurations with higher pressure achievable by centrifugal machine. Thank you, everyone.